Hi. So we're going to study very important theory. It's called the Pythagorean Theory. And there are about 10 important theorems were discovered by human beings in the history, and this is one of them. Okay. Well, let's talk about a little bit history. Okay. Thousand years ago, the Chinese guy discovered that if he walks 4 steps to the east, then back to the origin point, if he walks to the 3 steps to the north, then he find out exactly always it's a 5 steps here along the diagonal, okay? So it's amazing. He find out, he just measured, 4 steps to the east, then back to the starting point and 3 steps to the north, and find out exactly 5 steps from between those 2 points. Okay, so it's written in the literature. Okay, so that's why we know that. However, the Chinese people did not introduce a simple notation to describe this relationship. So it's very hard to modify, derive a more general formula. So that is a bad part. Okay, unfortunately, so notation is very important. Okay, so so it's another, this is a 3, 4, and 5. That's it. But anyway, it's mentioned in history. Okay, but it's not called a theorem because it's a very special example. So remember, when you're talking about special example, so you cannot use that to prove the theorem. Okay, and there is a so-called the Pythagorean theory. It says that if we are given a triangle, okay, and have 3 sides A and B and C, okay, so if C squared equals A squared plus B squared, then this is a back forward two statements here. Then the angle between this is alpha, okay, equals 90 degrees. Okay. So this statement, it's not just, okay, we always think, Pythagorean theory means given a right triangle, then C squared equals A squared plus B squared. But this actually, the converse is also true. If C squared equals A squared plus B squared, then alpha must be 90 degrees. Okay. Now, of course, there's a generalization of the theorem. Okay, in case if this is alpha, here's A and here's B, and how can I relate to C and A and B in terms of alpha? Right? Not necessarily be 90 degrees. So in general, okay. So C squared equals A squared plus B squared. Then something here we don't know, right? Okay. Yeah. So you're going to study this when you get in high school. Okay. So let's focus on this. This is a theorem, Pythagorean theory. It says that A squared plus B squared equals C squared. Okay. Now, besides the special triangle discovered by Chinese, okay, right triangle, you may have some other triangles. Yeah, we can have. So we find out. Let's look at some examples. Okay, some examples. Of course, 3 squared plus 4 squared equals 5 squared. Now, if I double it, I also get 6 squared plus 8 squared equals 10 squared, right? Or you triple it, right? And then 9 squared plus 12 squared equals 15 squared. And so essentially, those are same relationship, okay? So you just double the triangle, triple the triangle, okay? So those are special triangles. So I was trying to find a little bit more general formula so I can get many. When I say special triangle means the edge length is not necessary to be, there must be integers, okay? And yeah, special triangles, yes, I'm interested in special triangles was integer lenses, okay, side lenses, okay. So those are the three of them. I can multiply by 4, and I can even get more, I know. 4 is 12 square plus 16 square equals 20 square, and so on. Keep it going, you get infinite. But essentially, you only have 1 here, okay? So now I have another formula, 2n squared plus n squared minus 1 squared equals n squared plus 1 squared. So n here is the integer, okay? This gives you a lot of special triangles, okay? And this is true, okay, for any integer n, 2n is the integer, n squared minus 1 is the integer, n squared plus 1 is also the integer. Okay. So those are the integers. Okay. And in other words, let's draw the picture here. This is right angle. Okay, if here's 2n, this n squared minus 1, and the other side, as long as it's right angle, the other side must be n squared plus 1. Okay. Okay, so let's take a look at that. N equals 2. I think that's going to be 4 squared plus 2 squared minus 1 is 3 squared. 2 squared plus 1 is 5. So that's first. That's what we already got to that. Then n equals 3. Then I get 6 squared plus 3 squared minus 1 is 8. And 3 squared plus 1, right? It's going to be 10. It's not new. Essentially, it's the same. And you just double the previous one. Okay, then sounds like we cannot get any new here. Now let's try n equals 4. 4, 2n, it's 8. N squared minus 1 is 16. Minus 1 is 15, 15 squared. And then 16 plus 1 is 17. Okay, so this is a brand new triangle. And the Chinese did not discover that. Right? At least the recent, yeah. Okay, n equals 5. Okay, that would be 10 squared, 2n. 5 squared minus 1, 24 squared. 5 squared plus 1, 26 squared. Okay, so this one can be simplified. If you divide by 2, it will be 5 squared, 12 squared equals 13 squared. This is also brand new, right? Okay. Because all the numbers are even number, you can simplify. Just like here, this is simplified to 3 squared plus 4 squared equals 5 squared. And this is essentially not new. Okay. Okay, let's try n equals 6. When n equals 6, 2 times 6 is 12. 6 squared minus 1, 35 squared. 6 squared minus plus 1 is 37. So this is a new, okay? It's different from above, you know. Okay. Since 37 is a prime number, so it's no way you can simplify it. Okay. N equals 7. We stop at 7, okay? 14 squared plus 7 squared minus 1, 48 squared. 7 squared plus 1, 50 squared, right? Then this way I can simplify. It's going to be 7 squared plus 24 squared is 25 squared. Wow. So, okay. So you do have we have interesting, okay, special triangles. Now we can use these triangles to make as a type of triangle, right? So here I have a 24. That's 24, right? Okay. I also have an 8. It's 8, right? So I can use an 8 to make a 2 triangle, 8. And I have 8. So you can glue them together, 8. That's a 15. That's 15. Here's 17, right? Then other side, that's just 10 and 6. So you can have a triangle consists of 17, 10, and 21. So if I just only draw the picture like that, you probably don't see that it consists of two right triangle. And this is going to be 21, right? 21. 15 plus 6 is 21. Okay, given a triangle, yeah, 21, right? So the given a triangle like this, you know, can you find the area of the triangle? But if you know this consists of two right triangles, you can solve the problem, okay? Okay. So my question is, right? This is the way you can use it, right? Find the area of the triangle. It's not right triangle, 17, 10, 21. Okay. Now, if you did not recognize this consists of two triangles, then it's not easy to find the area. So you have to use Pythagorean. You have to use a Heron's formula, right? Or you're trying to find the height. Okay. Okay, so there are a couple ways to do, but if you recognize this consists of two right triangles, then the area is going to be half of the area of the first right triangle, 15 times 8, right? Plus as a half, 6 times 8. Right? Then you can find the you can simplify and then get the area, right? Okay, so we get 15 times 4 plus 6 times. Okay, so it's 84. Okay, now yeah, it's 84. Okay, now if you do not say this consists of two right triangles, then you can use a Heron's formula. Heron's formula area is going to be half. Area is going to be square root of, right? Square root of S minus A, S minus B, S minus C. Okay. So then the computation is a little bit complicated, right? So S is half of the parameter. Okay. S is half of the parameter. So 17 plus 21 plus 10. Okay. So you will get 21 plus 17. Right, divide by 24. Okay. So 24 is going to be the half parameter. Then area is going to be 24 times 24 minus 17, 24 minus 21, 24 minus 10. Then you have to, you get a perfect square inside, so that's why you can get 84 again. Okay, for the same reason you can get 84. Okay. All right. So this is I just said that if you memorize those special right triangles, okay, then you probably can help you to solve the problem quickly. Okay. Otherwise, you have to use the Heron's formula to solve this problem. Okay. So there are a couple of the right special triangles. Okay. The first special triangle is equilateral isosceles right triangle. If this side is A, this side is A, and here's a 45 degree, that's a right triangle. So the other side must be square root 2 times A. Okay. So it's not going to be integer. Okay. This special triangle is not going to be integer, but the angles are special. The edge lengths are not integer. Cannot be integer. If A is integer, square root 2 times the integer is not going to be integer. Okay. So, but I really want to know, yeah, this special triangle. 30 degree and 60 degree, okay? So how can we find the relationship if this side, if I use this side denoted by A, can you determine the other two sides, okay? So the idea is simple. I may duplicate this triangle and put the other side. So this will be 60 degree, that'll be 30 degree, and clearly, as this is 90 degree, this is 90 degree, right? So it's 180 degrees, so it's from a straight line. So what you get is you get an equilateral triangle, okay, because 60 degree, 60 degree. So that's why this side must be half of A, and this side must be square root of A. That's the height of the equilateral triangle. Okay, how do you do that? Well, you can get A squared minus half of A squared, and then after you simplify it, it's going to be A squared minus a quarter of A squared, so it's be 3 over 4 A squared, then it'll be square 3 over 2 and times it. Okay. All right. So those are the special triangles. We're going to use it. As I said at the very beginning, if you know the relationship of the three sides, they satisfy the formula for the right triangle, then it must be right triangle. Okay. So yeah, if you are given a triangle with three sides, this is 16, this is 63, 65. Okay. For example, if I ask you to find the area, first thing you have to double check is whether this is right triangle. Okay, maybe you memorize several special triangles. You're young, most of you have a super memory, but you can memorize more than your parents. Okay? So after you did lots of exercise, there's a special triangle. So you check that 16 squared plus 63 squared equals 65 squared. Okay. So verify this first, then it implies it is a right triangle. Why? By Pythagorean theory. Okay. The Pythagorean theory is a complete statement that's back forward. Okay. If A squared plus B squared equals C squared, then this must be right triangle. If it's a right triangle, then C squared equals A squared plus B squared. All right, so this is the right angles must be here. So that's why the area is just half of 16 times 63. And that is going to be, if you multiply out, it's 504. All right. So I'm going to ask you to do the next problem. Yeah, I have an isosceles triangle, 17, 17, and 30. Find the area. Okay, would you please work on this? Hey, anyone has answer now? Let's see who is, well, yeah, a couple of students were late. Now they're all here. Right, so geometry, okay. First of all, this three sides already given. So you remember, if the three sides is given, you can always find the area using the Heron's formula, right? Okay. But you can also use the Pythagorean theory to solve the problem quickly. Okay. So first of all, let me just So there are two ways to solve the problem, and the natural way is to find the height. Once you draw the line, and you know this is a isosceles triangle, so those two sides of a triangle are equal. Okay. So then this side is 15, this side is 15. Then by the Pythagorean theory, it's a 17 square minus 15 square. Okay. Now if you forget the special triangle, which gives you, the three sides, right? And suppose you forget it, how can I solve this problem quickly? Maybe h is not the integer, right? If it's integer, it's already one of the special value triangles, so you memorize, right? So how can I do that? So 17 minus 15, 17 plus 15, okay? And then I get 2 here, 17, 15, that's going to be 30, 32, okay? But 32 is going to be 2 and 2 to the 16 to the 5th, right? So then 2 to the 6th, that's 2 cubed. It's going to be 8, right? So 8 is the height. Now once you get 8, then the area is half of 30 times 8, and so 120. Right? That's how you get to 120. But you can always use the Heron's formula to find the area, right? And in that case, sometimes the area is not going to be integer. Okay. So the best way to do is to use apply the Pythagorean theory to find the height. Right. And in geometry, you need to draw addition lines. We have a triangle A, B, and C, and AB is a 2. The triangle ABC 30 degree. The triangle ACB is a 45 degree, and I want to find the AC. Okay, so what is AC? Okay, find the AC, which is X. Okay, so actually this triangle is completely determined because the angles are given, fixed. So if this is 30 degree and 45 degrees, the other angle must be, right, 60 plus 45, 105 degree, right? Right. But I'm saying that a special triangle like that, as long as one side is given, you can get all the three sides. Right. You are given maybe BC, you are even given AAC, but you should be able to get all the other three sides because the triangle is uniquely determined. Okay, the three angles are uniquely determined. The triangle may be large, it may be small, but if one side of the size is given, then the rest of them is given. It can be determined, right? Okay, so when you see 30 degree, this must be special triangle. So what they do is, let me redraw the picture here. And this is a 30 degree, here's 2. Here's A and B and the C and the right. So first you have to get is a 1. This side is 1, right? And then you put a D here, that's enough, right? So the height is 1 because 30 degree, right? The other side is 2, then side 1. Now then DC must be 1 because this is a 45 degree, then this also 45 degree, then it becomes an isosceles right triangle. So therefore, X is going to be square root 2. Simple, right? 1, 1, square root 2. Why it is 1? Hey, I said that's right. It's a 30 degree. 30 degree. If this side is A, this side is A. No, sorry. This side is C. This side is B. Okay, A is going to be half of C. B is going to be square root of C. Okay, that's coming from the special triangle. Okay. Yes. Yes, special triangle, 30 degrees. And then AD must be half of BC. Okay. Yeah. Okay, let me repeat again. If you have a special triangle, let me erase this and redraw the picture. Okay. All right, the special triangle. If this is 60 degree, that's a 30 degree, and here's a, let's call this B, this A, that's a C. Now, what's the relationship? Of course, C squared equals A squared plus B squared. Okay, but actually, B over C should be equal to 1/2. Okay, A over C should be equal to square root over 2. Okay, so B is half of C and A is half of square root over 2 times C. So you can replace A by square root over 2C and replace B as half of C. And you'll see this is identity, okay? This is just identity. All right, now a little bit more general, okay? If you are given a triangle, an isosceles triangle, okay? This side is this side is A, it's A, and this side is B, okay? This isosceles triangle. Can you express the area in terms of A and B? So you're trying to find the general formula. So you express the area of this triangle in terms of A and B. Okay, what are you going to do? Yeah, I told you there are a couple ways to do, right? For this particular one. There's these three sides are given, so you can use a Heron's formula. Right? You can make it easier. The other side I call it 2B, okay? Make it easier, okay? Otherwise the coefficients will be bad. Okay, this side 2B is side A and A. Okay. Now, by the triangle inequality, okay, 2A must be greater than 2B. Okay, otherwise this is wrong. Okay, so that implies A should be greater than B. Otherwise, you're not going to make a triangle. Okay. So remember A should be greater than B, right? If A is smaller than B, you're not going to make a triangle. Can you express the area in terms of N? Well, let's try and use a Heron's formula. I told you you can always use the Heron's formula to solve the problem. So S is half of the parameter. It's going to be 2A plus 2B, so just equal to A plus B, right? Okay, then the area is going to be square root of S minus A, S minus B, S minus C. All right, so what is, so actually A and B, oh, S minus A, S minus A, that's 2S here. Then S minus 2B, okay, because there's three sides, right? So A is S is A plus B, S is A plus B, then minus A, that's just B, and S minus A, that's just B. S minus 2B, okay, A plus B minus 2B, A minus B, okay? So you have a B squared taken out, so just B, and A plus B, A minus B, okay? Or you can write this as A squared minus B squared. So that is the expression for the area in terms of area. Yeah, I just want to make it easier to put 2B there as in the base. Yeah, another way to solve the problem is isosceles triangle consists of two right triangles. If this side is A, and here's a B, here's a B, here's A, right? All you have to do is just find the h, the height. Height is going to be A squared minus B squared. So then area is going to be half of the base and times height. So you get B times A squared minus B squared. It's much quicker way to solve it. Got it? All right. Our next problem I wanted to try, what I'm going to do is I draw an equilateral triangle, and then I draw another extended and connected. Okay, so this is A, B, and D, and C. Now what I have here is AB equals AD equals CD equals BD. Okay, those all the three sides are equal. Okay, what I know is BC equals square root 3. Okay, that's what we know. Find the area of the triangle. Okay, find the area of the triangle ABC. Yeah, why the height? I have a question there. The height by the Pythagorean theory, that's how you get the height. Okay, because by the Pythagorean theory, h squared plus b squared equals a squared. Then we solve for h, right? H squared plus b squared equals a squared. Then you move b squared to the right hand side and so forth. So how about this problem? You want to find the area ABC, the triangle. Now, I think the triangle is uniquely determined right now because if one side is given. Okay. The question is how do you find the height? How to find A and B, right? So you have to find out AB. Right? You have to find out because you have to find the AC, right? AC consists of AD plus DC. So as long as this is x, here's x, they're all equal, right? So that's going to be 2x. Then you also have to find the height. Now, once you know x, you can tell the height, right? So you can get the area of the triangle. Right? So I want you to try and think about. All right, anyone can figure it out? X? All right, let's see. I'm going to redraw the picture again. I don't want to destroy the original. Okay, so A, B, C, D. So this should be 60 degrees, right? Because the equator triangle, 60 degrees, 60 degrees. Okay. Since, yeah, this will be 120 degrees, right? Since this two is also isosceles triangle, so those two angles are same. So you have 60, so that'll be 30 degree and 30 degree, okay? Now, almost there. So here's a square 3, right? So you need to draw addition line to figure it out. So you draw the line. Okay, then this side will be square 3 over 2, square 3 over 2. Right? And clearly, so x is going to be what? X is going to be 1. Okay, x is going to be 1. Why? Because for the special triangle, if this side is x, this side is square 3 over 2, then that's a 30 degree, then x must be 1. Okay, so if x equals 1, then you can get the height h. Okay, right? The height h is going to be, again, that's a special triangle equals square 3 divided by 2 times x. Because why? It's another special triangle. Here's x. This is h. H should be square 3 over 2 times x. I said many times. All right, so that's the h. H. Since x is equal 1, so this is going to be 1, right? So what is the area of the triangle? The triangle ABC is going to be the base times the height h, right? Base is 2x, because this is also x, right? So x times h, x is going to be 1, h is a square 3 over 2 times 1. So the answer is a square 3 over 2. Oh, divide by 2. Hold on. Right. Let me double check, okay? X is 1, so h is half of 3. Yeah, that's h. Okay. The base is going to be 2x. Yeah, okay, that's correct. Okay, A, B, C. So square root over 2. Okay. So we use special triangles many times. But for the special triangle, once you know the one side, you should be able to get all the other side. Okay. For example, if you have a special triangle, 30 degree, if I have a 10 here, what is x? Okay, if this is one angle. Okay, can you tell me? All right. Anyone figured out? Oh. Right. So yeah. So you see, we can do step by step. This side is C, right? First of all, C should be equal to 20 because double A. And then X should be square root 3 over 2 times C. That's why it's a square root 3 over 2 times 10 times 20. So it's 10 square root 3. Right. Right. That's all. All right. Our next problem. My next problem is as follows. Okay, if I know the perimeter of a rectangle is 20, perimeter is going to be 20, and its area is going to be 19 divided by 2 square inches. Okay, find the length of the diagonal. Okay, let's find the length of the diagonal. Well, look at it. Right? You look at this rectangle. This is diagonal D, right? And this side is A, this side is B. Now we are given the parameter. Half of the parameter will be 10, right? Given this. And I also have 19 over 2, right? We want to find out D. D, by the Pythagorean theory, it's going to be square root of a squared plus b squared. Okay. Right, this is Pythagorean theory. So can you solve this algebraic problem? You're given two numbers, a plus b equals 10, a times b equals 90 over 2. Find the square root of a squared plus b squared. Okay, nobody hear me. All right. So how to solve the problem? Now, the most I say stupid ways to do is you you solve the quadratic equation. Okay, then you get a and a b, then you square it. Okay, yeah, you use a substitution. You solve for b from first equation 10 minus a, and put in second equation, you get equation in a. Then you get two solutions for a and for a. Then you get b. Then you square it. Then you take a square root and find out. But that's not the way. The best way to do is a squared plus a plus b squared is a squared plus b squared plus 2ab. Okay, that's the identity we use over and over again. Right? Can you hear me now? Yeah. Okay, I think my microphone is on. Okay, double check. Okay. So a plus b here, 10 squared, a squared plus b squared. Okay, and then plus 2 times 19 over 2. Okay, cancel it out. So a squared plus b squared equals 81. So b is going to square 81, which is 9. Okay. Yeah, I think everybody can hear you. You double check your microphone, okay? All right, so now next problem. I'm going to look it. We use a Pythagorean theory. Okay, how much time do we have here? Yes. All right, so let's look at the following problem. This is a right triangle. Okay. Here's A, B, and C. So this is a right triangle here, 90 degree. BC is going to be 63. And AC is going to be 16. Okay. You draw the line and perpendicular to get the D. Okay. So I want to find out C and D, which is the height of the triangle. Okay. Now to solve this problem, there are a couple ways to do. If you do not using area, okay, without using area, how can I do that? Okay. Without using the area, okay, areas. Okay, so don't want in all proof without using area. How can I find the height? So I'm going to call it H. Okay, and this side called X, this side called Y. First of all, by the Pythagorean theory, AB is going to be, right? AB is going to be by the Pythagorean theory. AB is going to be 65, right? Because this is a 63 square, 16 square, and after this thing, that's a 65. So what does that mean? That means X plus Y 65. Good. Then you apply the Pythagorean theory to the two triangles, right triangles there. So H square, okay, H square plus X square equals 63 square. Then H square plus Y square equals 16 square. So now you have three equations, three unknowns, X, Y, Z, X, Y, and this H, right? So you can find the X and the Y. Then once you find N and H, I think that we should find the H, X and Y first. Okay. Okay. So that's equation 1, equation 2, equation 3. And let's take a look at equation 2 minus equation 3. Okay, H is gone, so X squared minus Y squared equals 63 minus 16 squared. All right, now what I'm going to do, actually I can factor it, right? Okay, I'm not in big hurry to multiply this out, okay? So I know X plus Y equals 65. So that means X minus Y equals 65, 63 squared minus 16. Okay, that's X plus Y. But you have X minus Y, X plus Y is 65. So that is equation 1, that's my equation 4, right? So now from here you can get an X and a Y. Okay, once you get X and Y, you can go back to find H. H is what we find out eventually. All right, add them together. Equation 4 plus equation 1, you get 2X. Then I have 65 plus, and then I got 65 squared plus 60 squared minus 16 squared. It's a weird number, right? Okay. We know that 65 squared is going to be 63 squared plus 16 squared. So I think we should replace 65 squared by 63 squared. So I got twice of 63 squared because 16 squared is gone, 65. Then my X is going to be 2 cancel out, right? And I got 63 squared over 65. Okay, and similarly, Y is going to be 65 minus X. So after simplifying, I get 65 squared minus 63 squared. That should be 16 squared. Right, so now you have this. You have X and Y, we do it, right? And they look very nice, actually. 63 square, 16 square in the numerator. So that's x and y. Okay, add them together, you get 65. Okay, double check that. You know, x plus y is going to be 63 square, 65 plus 16 square, 65. Add them together will be 65 square, and that's just 65. Okay. All right, so you can use one of this to get h. Let's go back to the equation. I can use one of them. Okay, so use the h square. H square is going to be 63 square minus x square. Okay. So where's my x? Oh, x is over there. Okay, then you simplify it. It's a perfect square. How can I do that? Well, I take 63 square out. I get a 1 minus 63 square and a 60. Huh. Am I right? Yeah, this will be 65 square. Okay, so the numerator will be 65 square minus 63 square. Then that's just 16 square. Okay, then 65 square. So this is a perfect square. So h is going to be 63 times 16 divided by 65. Okay. So that's what we get. You can multiply this out to the numerator to find the step, and we can leave like that. Okay. Now, using the same idea, okay, using the same idea, one can prove the Heron's formula. We keep talking about Heron's formula. Okay, formula. It says that the area is going to be square root of S minus A, S minus B, S minus C, right? So if you have A, B, C, that's what we get. Okay. So what I'm trying to do, how do you prove, how did Heron got this formula? Heron knew that once the three sides are given, you can uniquely determine the area. So the area should be expressed in terms of A and B. So what they're trying to do is, first of all, you have three angles. I think one of the angle must be large enough, okay? So that suppose if I draw the height, it will land on the other side, okay? We can assume that that's a picture, right? So this side is x, this side is y. So the same idea as I can show you, x plus y equals c, and x squared plus h squared equals a squared, and then y squared plus h squared equals b squared. Okay, so you can solve for, you can solve it for x, y, and h. Now, once you get h, once you get h, it's the same idea, you repeat it. Okay, once you get h, let's find out the formula we get. Since I don't have much time left, so I'll show you the formula, right? So actually, we will get h, okay? So the h, finally you will got, let me just list the formula, okay? So actually, use the same idea, you get a square, x is this, okay? First of all, using x. Then h is going to be square root of a square minus x. So you plug this into here, and that's what the Heron did. So it's a square minus 2c c square plus a square minus b square. Right? Then you will get. Okay, almost done. Okay, then you know it's already expressed. You can call it, this is a h. You can simplify, okay, and actually you can simplify to something like that. and here's b plus c minus a plus b minus c, a plus c minus b, and then a plus b minus plus c. Okay, so you will get something like that. Okay, it's not a problem because this is square. Then the area is going to be what? Area is going to be half c times h. Okay, so cc canceled out. Okay, cc canceled out, and you get a quarter of, no c here, quarter of b plus c minus a plus b minus c, a plus c minus b, and here a plus b plus c. That's a Heron's formula, okay? That is a Heron's formula. Okay. And that's how to do it. Okay, so if you learn the formula, okay, but you have to ask yourself, are you able to derive it by yourself? Okay, I use the same idea, like what we did for the last problem. Okay, we trying to find the h height or find the area. Okay, if this side is 5 without using Heron's formula, all I have to do is find the h. Use the 3 equations from the Pythagorean theory. Okay, then you actually can. You don't need to specify those special numbers. Okay, you can use as arbitrary 3 numbers and derive the formula. A good student will do that, after you do the special examples. And why not? Assuming you did not know Heron's formula, and why not? I derive the formula by myself, right? Just assume A, B, C, arbitrary numbers, and all you have to do is find h. And then you have 3 equations. You can find h. A little bit complicated, but you can get a formula. That's how I just try to explain to you. That's how a mathematician is doing their research. Before Heron, nobody has this formula, and he did some special examples. Then you immediately will ask yourself, why? I can always do this type of problem when you give me 3 sides, specific sides. I can find the formula for the area, right? So why not just assuming the 3 sides A, B, C? Let me derive the formula. And he found out and he published. So I just give you an example how the mathematician is doing research. In the biologist, the chemistry is the same way doing. Okay, when you do the experiments, you pay attention, you get, sometimes it's not like you decided to do some research, but you probably came out some byproducts and you pay attention to those byproducts, maybe you discover and make a greater discovery and get a Nobel Prize. Okay, so but you have to be alert to what you find out. Okay, don't let them pass away. Just pass by. Okay. All right, let's stop here and see you next class. I'm going to send you the homework. Okay, bye-bye.